In this video, section 2.1, solving linear equations. We're just going to jump right in and take a look at the equation 3x plus 7 is equal to 16. Now, an equation is solved when we know the value of x that makes it true. So what we're looking for is x to be equal to something. We don't have that. We've got a bunch of other stuff going on over here, like addition by 7. We don't want to add 7. We want to add 0. So let's subtract 7. And we'd have 3x plus 7 minus 7. That simplifies. We'll be left with just 3x, which is better, but still not good enough. We want just x. So we'll divide by 3. We'll have 3x divided by 3, and that will just give us x. But we also need it to be equal. And for this expression to be equal to this one, we need to take and subtract 7 from it as well. Likewise, we're going to have to divide by 3 as well. And that will get us our solution. We can go ahead and we can check. 3 times 3 plus 7 is 9 plus 7 is 16. We found the solution to this equation. In general, if we have something of the form like this, ax plus b is equal to c, then that means that x is equal to c minus b divided by a. Okay. Let's take a look at another example. We'll have 1/3 x minus 8/5 is equal to 9/3. That's a lot of fractions, but if we look up here, this is just a true formula. There's nothing like, oh, a can't be a fraction, or b has to be greater than 0. No, they're just numbers, a, b, and c. So we can still use the same method to solve. We're going to subtract a negative 8/5 or add 8/5 to both sides of this equation. And we'll fill in the rest around it. These will cancel, and we'll have 1/3 x is equal to 9/3 plus 8/5. Not the best, but we can just leave it as is. Next, we need to multiply by the inverse of 1/3. That is 3. And we need to multiply both sides of this equation by that. And since we're multiplying after we added 8/5, we have to have these parentheses here. These cancel. We're left with x is equal to 3 times 9/3 plus 8/5. But I'm not too happy with that. I want to take this and simplify it. So this is 3 times 9/3. This has a denominator of 5, so I'm going to multiply top and bottom by 5. Likewise, 8/5, I'm going to multiply top and bottom by 3. 3 and 3, 5 and 5. So we'll have 3 times 45/15 plus 24/15. This gives us 3 times 69/15. And this will cancel to give us 69/5. And that's x. I have one last example here, and once again, it's a spicy one. I'm going to take 3x minus 7 divided by 2. To this we'll add 8 and we'll set it equal to 10. So first thing we're going to do is we're just going to stick with the same method, inverse, reverse, and that means we're going to look at doing this first, then taking care of the 2, then this, and finally we'll get rid of that 3. So first things first, we'll subtract 8 from both sides of this equation. We will have this will be equal to 10 and 8 to 7 minus x third. Alright. Now these will cancel out and we'll be left with 3x minus 7 divided by 2 is equal to 2. 2 is now our focus, so we're going to multiply both sides of this equation by 2. Okay, the left-hand side simplifies to 3x minus 7. Our right-hand side is 4. We'll add 7 to both sides. This will give us 3x on the left-hand side is equal to 11. And now we just need to divide both sides by 3. 3x divided by 3 is equal to 11 divided by 3. These cancel out. We're left with x is 11 thirds. That's our solution, and that's also the end of section 2.1. Thanks.